Hello everybody, this is a video that will take care of my beloved Tektronix TDS 784A, which is simply dead while I was attempting to repair another instrument. The instrument simply switched off and won't turn on anymore. By switching the rear power button, this one, I can only hear a small click, like a relay click. So, but it's simply dead, no life signs. And what I have seen, I'm trying to give a little bit of more light. There is leakage from capacitors, which I still need to find which one, or if there are some more than one. But as you can see, I hope we can see on camera, there are oxidation signs, especially over there in the where is the flap that is riveted on the PCB. Let me see if I can look at that. So it's clear, as you can see, that is wet. So for sure I have leakage from some capacitor, and I hope this is the cause. So I'm going to remove some capacitors and see if I can find some leaking capacitors, and then I will be back to show what I will find. The removal of the first one, capacitor, which is removed exactly from here, already has shown leakage signs. As you can see, there are leakage around the terminals. So for sure this series of capacitors, which are in parallel, should be, I would say it must be replaced. They are labeled 2700 microfarad, 10 volts. So let's see if I have some replacement of that. As you may see, two of these three capacitors are leaking, and they are all in parallel. And look how many leakage signs are around the area where they are mounted on. So time to clean with some vinegar and see the result. Just for curiosity, I want to check the capacitor. Of course, is the one of that shown leakage signs. And if you look at the meter, well, it says that has not a lot of ESR. Actually, it says 0. Let me read down the test. 0.02 ohm, but and 2.8% of loss. But the important data is the capacitance. In fact, is showing more than 3000, so it's 3149. This doesn't mean that this capacitor has an higher capacitance than the new one that I'm lucky enough to have in my hand, but it's just simply because there is an internal leakage. So since this instrument measures the time for charge the capacitor, of course leaking require more time and indicate an higher capacitance, but it's simply leaking. So sometimes this kind of testing with these instruments doesn't tell you exactly that the capacitor is faulty or is leaking. So when you have an higher capacitance, for sure you have an internal leakage. We are talking about more than 500 microfarads than the specification, so for sure there is a leakage to have an increase of such capacitance. So I'm going to rinse the board with IPA. I have just spread a lot of vinegar in order to stop the oxidation process. So I'm going to rinse with IPA and then install the new capacitors, but I already have seen that also those capacitors, all four, are leaking, and also this one. So for sure need a recap. Maybe not entirely, but almost. These bigger capacitors must be replaced, and hopefully will fix the problem. First series of capacitor has been replaced, but be very careful to attempt to repair this kind of equipment. If you are not familiar, I strongly suggest to don't do it. These are very dangerous. Power supply can leave inside the capacitor a lethal voltages, even after several times that the equipment has been switched off, and especially when they are not functional. The bigger capacitor here can store up to 320 or 30 volts, so it's very dangerous and lethal. This is not, of course, a training course. This is just I'm just showing what I'm doing. So again, if you are not familiar with such devices, I strongly suggest to don't attempt to repair. However, this is what I have done. Replaced the first series, and I discovered another series of the same value that I'm going to replace, since if there is leakage on those that were living here, for sure those capacitors here have the same age, for sure. If they are not yet leaking, they will do very soon. And another point is that it's very simple to damage the pads. Let me see if I can remove the glare. Okay. It's not really visible, but two of those pads were easily removed by the solder iron just by touching them, since they were very oxidated. I've been able to solder in the small tube that connect the lower and the upper layer of the PCB. So can work, but again, be very careful, because it's very fragile, this type of PCB. So I'm going ahead and replace all the capacitors that I will find leaking. And I want to show you another thing. As you can see, there is a darker area here, and it is exactly in the opposite side of those two capacitors here. So for sure those capacitors has some bad leakings, and perhaps those two as well. No bulging signs, but I think that I need to replace these four, the three on the side here, and probably also this one. I will check later. So I will come back when I will finish the replacement. Well, despite I was thinking to skip this video to the end of the capacitor replacement, when I have removed the two capacitors that were showing leakage even from the opposite layer, look what I have found below them. So how badly is oxidized by the capacitor leakage, and these are the capacitors that were mounted on, and well, it's clear that they are fried. So I will grab the meter and I want to test them. Last but not least, last capacitor. Look at that, very badly leakage, and there are major signs of oxidations since one terminal is completely gone. There is no any more terminal, and is not even in place over there. Everything has been corroded. This is the worst one, so I believe that this will be not easy to clean and remove the terminal residues. So let's see if I can clean it in order to be able to install the new one. Okay, so I have replaced all the electrolytic capacitor, at least those of big capacitance. I left the original ones that I have tested in the circuit and appear to be good. So time to put back in the instrument and see if the replacement of those capacitors fix the problem that doesn't power on. So let's go ahead with the reassembly. Everything is back in place, so it's time to see if the capacitor replacement has fixed the problem. So time to power on, and yes, that is a good sign. The fan is spinning, all the lights on the front panel are switched on. Yes, for sure that fixed the power supply issue, so the oscilloscope is back operative. Well, since this oscilloscope has a problem with the channel 4, since when I got it, as you can see, I can switch on all the channels, but I can only see 3, and channel number 4 is not visible. And if I'm going to the error log, I will find that there is a clipping problem, probably because the input is faulty or some other kind of issue. And it's happened that I have in my hand another unit like this, completely faulting. So I will try to swap the input attenuator, the hybrid circuit that is in the input, and see if this fix the problem. So I will need in the future to buy another hybrid circuit, since I don't want to destroy the other unit because it's under fixing, so I want to have also the other unit operative. So let's see if we can save this oscilloscope and bring back to the full working condition. You can see I already have removed the acquisition board, and I also have removed already the number of screws that hold in place the input attenuator. Okay, so look at that. Okay, let me put this aside. Right. So this is the input hybrid circuit that make the attenuation of the signals that is fed in the unit. So, well, you know what, since it's so difficult to reach this point, need to be removed also the instrument front bezel. So I will just swap two of this hybrid and make the instrument to make the signal path self-calibration, and see if swapping this circuit will be the channel number 3 to be the faulty and channel number 4 bringing back to working condition. So this will give us the information required to understand if one of this, this one is faulty, or is some other items in the acquisition unit that is faulty. So let's try to do the swap. I have already removed both and swapped the channel number 3 hybrid on 4th, and so I will put this in channel number 3. In order to remove this hybrid, I had to desolder here, this point, the small contact that is over there. I will try to show you. Okay, so here we have this small contact that is coming from BNC connector. Oops. So okay, so I just need to resolder here and chamber number 4 as well, and reassembly on the acquisition board and test on the oscilloscope if it makes some difference. Acquisition board back in place, so time to test. Okay, let's see the behavior. So I will switch on from the microprocessor board, since I'm not having the front bezel. And let's see. Okay, so the scope boot normally. For sure I need to remove this. Let me grab the rubber keyboard contacts. Okay, menu is gone. So channel number 2 normal, channel number 3 normal, channel number 4 again not normal. So for sure is not the hybrid the problem, since as you can see channel number 3 is visible normally. So however, let me try to do the self-alignment. I will be back. And as you can see, the instrument is giving me a compensation error, and still channel number 4 is not visible. So if I remove the menu, again, yeah, as you can see, we can have 3 channels but not channel 4. That still is visible, the channel indication flag here, we have the other 3 channels that of course are working. I have not checked with the probe, but I'm sure they will. So yeah, it seems that we have a different problem here. So even if I put all the way up or all the way down, I'm not seeing nothing, as well as if I try in all the point here in the middle. So yeah, seems that we have a different problem. And this is the acquisition board of the other unit that I'm attempting to repair. So let me switch off this one, and as you can see here we have 4 ICs which drive the input attenuator relays. So for sure those are not involved in the problem, since if I change the input attenuation, the relay is on channel 4 clicking, so that seems not to be the problem. And since I don't have any schematic of the unit, I need to figure out what could be. I'm seeing 4 different but same component, 4 ICs that maybe they are in the path of the amplification. And for sure then we have those big ICs which are the input amplification and conversion. I'm not quite sure if these are the real analog to digital conversion, as the model number let me image. However, seems that it's not easy to trace the problem here. So those ICs should be the analog to digital converter, and these are, well, they made also sort of digital work, since they are producing the trigger signals, and I believe also they store the amplification ratio when made the self calibration. So that also could be the issue. So, and that would be a problem, since they are not available on the market. So let's see in the future what I will find. Okay, trying to troubleshoot the channel number 4 on the oscilloscope. I was poking around and making resistance measurements, and I make also a comparison with the other bird that I have in my hand. And what I found is this. I just make it this lay here. I remove the glare. Let me see if I can manage some way. Okay. So on channel number 4, which is exactly over there, you can see here the indication. There are those tiny parts which are labeled C. Of course they are capacitors, and they are labeled E, which I'm not really sure what they mean with E, but this is what I have found. All the let's see if I can have all in the monitor. Okay, So this is E1113, which is 27.5 ohm. If I measure all the other E components, is measuring almost zero, or maybe is the lead resistance, what is showing now the multimeter. So it seems like a jump or a fuse or 0 ohm resistor or something like that. And it seems that this is not zero. If I probe also on channel number 3, the same component, that this is labeled E1113. If I'm going to channel number 2, I should find E1213, and it's 0. If I'm going to that was number 3. Number 2 channel, 1313, 0. So this is different. I'm not sure if it's open and it's reading just the other components, but for sure here we have a problem. So of course in the other board, if I go to measure the same component on the other board, it's reading 0. So here we have a problem. I hope that it's just a jump, so I can make a jumper with a wire, or let's see if I can find some similar components. Okay, this is the tiny parts that I have removed. So this is the multimeter. So let's check the resistance, and I hope you can see is 116 kilo ohm. So we can consider it as open, since it should be a short circuit. So what I have done, since I don't have in my hand any replacement part like that, I have simply mounted in two 22 ohms each, that in parallel give me 11 ohms. But if I'm going to measure, let's see if I can make it inside everything. So now I have 7, almost 8 ohms. But the reason why I have done like that is that I don't want to make simply a jump, because if I have a short circuit somewhere, I don't want to burn anything. So this small resistor should be burned out. I'm not quite sure that they have the same power of this original component, but it should be safer to install two resistors instead of a simple jump. So what I'm going to do is to put back in the instrument the board and see if it makes some difference. Alright, everything is back in the instrument, so it's time to try to power it up. Hopefully I will not see any magic smoke, since I have tested there are not evident short circuits, but we never know. So cross finger. And maybe I not have switch it on right. So second try. Okay, a good sign. Oh, no, magic smoke, magic smoke. Yeah, for sure we have a short circuit here, so we need further investigation here. Okay, Making more tests, I find this, if I measure the resistance across this capacitor is 0 ohm. If I'm going to the same capacitor of the other channel is measuring 8 ohm. And another thing that I have found is that the resistor or the capacitor, which are connected together here, are connected to this IC. This IC is a power IC which select and drive the attenuator release. So I'm not quite sure if the problem is the IC itself or the capacitor. So I will lift just this leg, since it's the first one in this row. It's very simple to reach it. I will try to lift the leg and see if the short circuit disappear, and so try to narrow down where the problem lies. I've been able to lift this leg, just applying some flux with a small screwdriver, applying just a slight pressure. So now I also have removed the amount of solder with the braid. So let's see with the ohmmeter what we will have. So I'm still having short circuit. So, and indeed this IC looks okay. So could be the capacitor. So let's try to remove the capacitor. The capacitor is removed. Is here. And let's see what we have now on the meter. So here we had, oh, look at that, short circuit disappeared. So it means that this should be short circuit. Yeah, look at that. It's a short circuit. So the capacitor is the cause of the fault, and hopefully this will revive the channel number 4. So what I'm going to do is to resolder the leg that I have lifted. Just apply a tiny bit of additional solder. That's okay. So the instruments for do this job is not the right one. It's a very big tip of soldering iron, but it do the trick. So what I'm going to do now is to clean all the flux residues and see if I have some capacitor that I can replace that. Since there is no way to understand the capacitance of the removed capacitor, I have simply removed another one, just was mounted close to it with the same code. This is the one that is faulty, and there is 4E, let's see, T4E, so it's very difficult. However, what I've done, I have simply remove it and mount it on the component tester, and let's see, let me remove this wire. Okay, so it's a, let me switch on again. (10 microfarad). So I believe that this is a tantalum capacitor. So let me test the faulty one and see what they say. This is probably not making contact. I was expecting to see a resistor. And indeed 0.4 ohms resistor. No, sorry. Look at that. This is the other capacitor. I don't have in my hand an SMD component. Moreover, is a non-polarized capacitor, and that is quite difficult to find. So I have traced. Actually, there is plus voltage. So I just mounted a tantalum capacitor, polarized capacitor. So let's see if this makes some difference. I have partially reassembled the board, so I will flip the instrument and see if makes some difference this replacement. Time to see if we have again magic smoke or if we have different behavior. So I have put the instrument on a side in order to see if any magic smoke coming out from the board as before. So, but hopefully don't. Let's see if the instrument can. Okay, so no magic smoke. That's is a good sign, very good sign. Okay, so let me focus on this screen. Channel number 4. I'm not seeing any trace, however. Oh yes, look at that. There is the trace. Oh my goodness. The channel is repaired. It's fixed. Let's see if I add the other channels. Number 3, number 2, and number 1. 4 channels. So let me switch off the instrument and make a different position of the camera and try to attempt the signal path calibration. Okay, I'm going to start the signal path compensation, and since it will take several minutes, I will just come back when it will finish the process and see the message at the end. If, as you can see here, it's failing the signal path, since there was a channel number 4 that was not working. And this problem was also avoiding me and prevent me to insert the active probes and make the probe calibration, because the signal path fail stopped the probes compensation process. So let's see the behavior in the end. It seems that we are reaching the end. Oh, look at that. Signal path pass. Oh, really happy, huh? Well, this instrument, despite is a bit old, it's still a capable instrument. It's 1 gigahertz, 4 channel and 4 gigasample per second instrument, and look at that, it's beautiful. So now I will give a bit of cleaning, and for the moment I will leave the components that I have just assembled like that. I will order the new components, and when I will receive, I will just replace. So this is the instrument completely reassembled. Is performing again the signal path compensation, since I wish to have it again with all the shield in place. I mean, the metal case is a shield, of course, so it's well warmed up, and yes, it seems that everything is fine. As we can see here, it has just passed the signal path compensation. So time to make some measurements with channel number 4. So let me remove this menu. I have also changed a little bit the color settings in order to have a better view. So I'm going to install this P6245 1.5 gigahertz probe. Okay, so not easy. Okay, let me reduce the scale. It seems that you don't like it. Okay, so let me connect to the calibrator output, put the auto set. This ground terminal here is broken, and okay, so let me put that should be okay for the purpose. So okay, let me switch off the other channels, leaving the channel number 4, source channel 4, and let's see if we have some. All right, look at that, we have sign of life in the channel number 4, and this is the very first time that I'm seeing the signals coming from the probe compensation, since I was not able even to calibrate any probe in any channel because of the signal path problem. What I'm going to do is to compensate. Okay, so it seems that you don't like this probe. Well, actually I have 4 probes, all of them have some problem, so I think in a future video I will fix or at least try to fix them. Okay, so it seems that this is something that we can't do it right now. However, as you can see, all the channels now are operative and at least visible, but I already know that the other 3 channels are working. So I think for this video it's enough, and I hope you enjoy it, and I hope that somebody that's having the same problem, this video can be of help. Of course, this is not a tutorial, this is just a show of what I have done. So if you do such repair, you attempt to do such repair, you are doing at your own risk. And these instruments are running at very high voltage in the power supply that you have seen I have repaired. So take care of your health, because those instruments can be lethal. But if you like the video, please give me one thumbs up. If you don't, you know how to do. And don't forget to subscribe, and I will post more videos about these instruments. So stay tuned. Bye.